Hey everybody, welcome back to another fun and exciting geometry class. Today we'll be in lesson 4.12, proportional segments in a circle. That is on page 212 in your book, page 212. And check this out, lesson 412. I like it. I like it when numbers do that. It's kind of a coincidence. Maybe some think it's not a coincidence. You never know. So proportional segments in a circle. Theorem 63, you can look down here at the screen and then also look in your book. All right, Theorem 63 says if two chords intersect within a circle, then the product of the segments of one is equal to the product of the segments of the other. This is one of those ones where you just kind of have to see it to make it make sense in your brain. So let's go ahead and take a look at this. And what we're saying is we're basically saying that, okay, these are the chords right here. So AB is a chord, right? And CD is a chord. But notice they cross each other, and they cross here at this point right here called point P. And so if we go back here, it says if two chords, that's what we have. So AB is a chord and CD is a chord. If they intersect at a common point, all right? So that's what's going on. They intersect at a point within the circle. So a P is inside the circle, which would make sense. You couldn't have a chord intersecting outside of the circle. So it's intersecting inside of the circle. Notice that it says these are proportional. Doesn't use that exact wording, but they are, because notice what it says. Then the product of the segments of one is equal to the product of the segments of the other. That's what proportional means. So here we go. We have a couple of things going on here. What we need to do, I mean, you could write it a couple different ways. You could say that, okay, AP, that's one segment. So AP times PB. Okay, so that's basically this segment times this segment is going to be equal to this segment, CP, times this segment, PD. You could also write it as a proportion. How does that look as a proportion? Well, the way that it looks as a proportion would be something like AP over, now you got to be careful because notice that these are being multiplied by each other. So that means that they are across from each other. So equals, and then we have to put PB down here, okay? Because those are being multiplied together, okay? That's how proportions work. And then CP and PD. Now technically you could swap those if you want. It doesn't matter which order the multiplication is in, but CP and PD have to be across from each other. AP and PB have to be across from each other in other words, these two segments right here end up being across from each other in the proportion, because if not, then they don't get multiplied by each other. And what the theorem says is that to be multiplied by each other, then they must equal the other one. We'll practice one of those in just a little bit, but for now I'll just kind of leave that right there. Corollary 63.1, the product of the segments of any chord through a fixed point within a circle is constant. So we could go back up here and we could say, okay, so any line we put through that fixed point is going to have this constant about it. What does a constant mean? The constant means it's going to have this proportion to it. In other words, it's going to equal these same things. We could add this one to the list. All right, so we would have to call this like D, we'll call this one E and F. All right, so E and F. So we could also put in here basically that E and F, this section times this section. So FP times PE. Okay, it would also fit into this. So in other words, this would also be equal to all of those. Okay, doesn't matter where, and you can kind of see that, right? Like this part of the line is quite a bit bigger, but then this part is quite a bit smaller. So it's going to end up being equal no matter where, as long as you're going through this fixed point of P. That's what that means. All right, so that's corollary 63.1. Theorem 64. If from a point outside a circle, a tangent and a secant are drawn to the circle, then the tangent is the mean proportional between the secant and its external segment. Okay, so what does that mean? Well, let's first of all start with secant and tangent. Okay, so what is a secant and what is a tangent? Well, a secant is a line that starts outside of the circle, it crosses all the way through the circle, and it ends on the circle. Now, this other line here is what's called a tangent. Now, the tangent could keep going, right? That would be fine. And technically, the secant could keep going as well. But we're going to end both of them. And for this example, we're going to end them both on the circle, okay? So there's going to be a point right here. All these are going to have points. So what they're saying is, in this case, when you have a secant and a tangent from the same point, point P, it's outside of the circle, okay? So the secant comes through from P to A, and then the tangent comes through from P to T. Now here's what the thing says. Then the tangent is the mean proportional. So in other words, this piece of line right here, PT, is the mean proportional between what? Between the secant and its external segment. So what's the secant? This whole line right here is the secant. Okay, now it's not just talking about this. Don't get confused. That's not a secant, that's a chord. Okay? So the chord starts on the circle and ends on the circle. We're not talking about a chord, we're talking about the entire secant, AP, and its external segment. What's the external segment? The one that's outside of the circle, PB. So in other words, it's this whole piece plus this piece, okay? And then this secant is the mean proportional. So what does that look like in our ratio? That looks like this right here. We have PA, all right, that's this whole piece, PA. And then we have PT is the mean proportional. PT is the tangent. And then we have PB, this exterior segment right there. All right, so what does that mean? That means that if I multiply these two, it is going to equal the same thing as squaring the tangent, or the PT line in this case. We're going to come back and we're going to do one of those as well here in just a second, but let's kind of finish up this lesson with corollary 64.1. It says the product of any secant from a fixed point outside the circle and its external segment is constant. The length of the tangent from that point is also constant. So in other words, when we're talking about this, like the product of this is always constant, and it doesn't matter where that goes. So in other words, if we put one over here, it's going to have that same constant when you multiply it together. So it's kind of hard to explain, but if it's, 7 times 7, let's just say, then that would be the same as this piece times this piece. All right, so the product is a constant. It doesn't change. The length, the product of any secant from a fixed point outside the circle and its external segment is constant. So it's just kind of reiterating that. It's just going back over it. This piece, okay, this whole tangent and this piece is a constant. What is the constant? The constant is actually the tangent. So if you're looking at the secant, you know how long the tangent is going to be based on the whole secant and its times its external piece. That's going to give you the tangent. Now, if you're looking at the tangent, so let's just say you're looking at one or the other. If you're looking at the tangent, you also know what this is going to be. What this times this is going to be. You're getting the mean proportional here. So their values are constant. They don't change. They can't change. Unless you change where that point is, if you move it farther or closer, then it can change. But when that point is consistent, these two values are constants. They won't change. They can't change. Okay, So the last thing that you need to know here from this chapter, the last corollary 64.2, if two or more secants are drawn to a circle from a fixed point outside the circle, then the product of one secant and its external segment is equal to that of the other secant. So what does that mean? So if we draw another secant to this, and we'll draw one right down the middle, okay? So that's not quite right down the middle, but pretty close. Now that one's a little bit longer inside the circle, but it's a little bit shorter outside the circle. We could draw another one. I'll draw one I'm trying to draw some extremes here. So we'll draw this one. This one is also a secant. You're like, it's pretty close to the tangent. Yes, it is. But it's not the tangent because notice it cuts through the circle right there. The tangent just goes to the edge of the circle and touches the edge of the circle. This one is actually cutting through the circle. Now, that one seems like maybe it's not going to be the same, but trust me, it's the same. It's product, okay, so when multiplying these two pieces together is going to give you the same thing. All right, let's do a couple of these. Let's just kind of have some fun here, and let's do a couple of these from the work, from the exercises on page 213. I think this is number 1. And maybe this is number 2. This is 1 or 2. I don't remember which one I picked. But anyways, you can kind of see that. Looks like it's number 1. So here's the idea. Here's what we want to do. We want to take and we want to solve this based on Theorem 63. So let's go ahead, and the first thing I always do in geometry is I always draw what I'm dealing with. So it says based on Theorem 63, so I'm going to draw the circle that I see in Theorem 63. And now I just want to take this information. PB is 2, so where's PB? All right, it's right here, so that's going to be 2. AP is 9, so I'll make that one 9. And then PD is 3, so this one right here is 3. And it says find CP, so this is our X right here. This is the one that it wants us to find. Now, what you want to do is you want to turn this into a proportion. Now remember, what I said was AP and PB have to be opposite each other. They cannot be across from each other. So we'll put 9 and 2 across from each other. Now, the other thing that I said was technically the 3 and the X can go either place. It doesn't really matter if they're up and down as long as these are across from each other. Okay? So what we'll do is we'll put 3 here and we will put X up here. All right, so we're going to do this cross multiplication right here, and we're going to get 18 equals 3x. We're going to divide both sides by 3, and we're going to get 6 equals x. So x equals 6. So our value of the PC line is going to be 6. So that's how that one works. Pretty simple. We've been doing a lot of those proportions. You should have been able to follow along there. All right, let's do another one. This is, I don't remember one, maybe number 5 or 6, something like that. And so now we have, it's telling us to use the next theorem, Theorem 64. So I drew a picture of what Theorem 64 has for us. And it says if PT is 24. So we're going to put 24 inches there. And PB is 16. Find PA. So we're finding this one right here. We're finding this big section. Now what we need to remember is that what is that called? That's the tangent, is the mean proportional. So we're going to draw our proportion. The mean proportional is the tangent. So the mean proportional is going to go like this, right? And then we can put those other two on either side. It doesn't matter. Again, kind of the same logic that we just talked through on the other one. So we could put 16 and x right here. And then we're just going to go ahead and we're just going to do that. So we're going to multiply that out. So we're going to end up with 24 squared equals 16x. We'll divide both sides by 16. And I'm just going to do this one kind of together. I'll make it a fraction. And your calculator, you got to learn how to use your calculator. So everybody's calculator is just a little bit different. So I'm going to do 24 squared up top. In the denominator, I'm going to do 16. All right. And then we're just going to hit equals. And that equals 36. So my answer there would be 36. We'll go back up here. So this one from A to P right here is 36. And that would be inches, obviously. So remember, just to kind of plug it into those proportions and then just find the missing number because you're just going to be looking for a number there. So just work those proportions, and that's really all those theorems have for us, is basically telling us that it's proportional. So we're just going to work those proportions and we're going to get the answers. All right, that's all I've got for you in this lesson. Hopefully you learned something there. If you missed anything, make sure to slide it back, watch it again. We'll see you later. Have a good one. Bye-bye.